Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start Lecture 2 of Module 6. The topic of the lecture is Temperate Cyclones, Origin, Characteristics and Associated Weather Conditions. The video is being recorded by Dr. Pallavi Opreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun, Uttarakhand. In our previous lecture, that is lecture 1 of module 6, we have already discussed how fronts are formed. What are the different types of fronts? Today in this lecture 2 of module 6, we will be starting with temperate cyclones, since it is a very important concept associated with the formation of fronts. So herein we will be discussing the mechanism of formation of temperate cyclones, their origin, their path of movement, how they move from one place to another, their track and their development process. In the meanwhile, we'll be also discussing how temperate cyclones impact the general atmospheric circulation, weather and climatic conditions in different regions of the world. So let's begin. The main objective of this particular video is to understand briefly what cyclones are and give a general classification of cyclones. And then we will move on to understand in detail what are temperate cyclones, what are their source regions and track movements of temperate cyclones, major characteristics of temperate cyclones including shape, size, wind systems, orientation, temperature, etc. of temperate cyclones. Then their origin and development through polar front theory will be discussed in this particular video. And finally, we will be understanding what are the weather conditions associated with temperate cyclones and different types of temperate cyclones. So this is what we are going to cover in this particular video. Let's begin. Let's begin with the general understanding of what cyclones are. So cyclones are atmospheric disturbances which are associated with irregular wind movements involving closed air circulation around a low pressure center. So basically cyclones are center of low pressure where the lowest pressure is found in the central core region and the pressure increases as we move outside towards the peripheral regions, because of which the wind movement is from the periphery towards the inner central low pressure core in such a way that the circulation of winds towards the low pressure center is in anti-clockwise direction in the northern hemisphere and it is clockwise in the southern hemisphere. And usually cyclones are accompanied by violent storms and bad weather, because when they becomes very extensive and they attain gale force, these atmospheric disturbances or cyclones are called as cyclonic storms also. So cyclones are basically the atmospheric disturbances, extreme weather conditions which are associated with the low pressure central core and the associated wind movement, where the wind movement is from the outer peripheral regions of high pressure towards the central core region of low pressure. Atmospheric disturbances associated with low pressure systems are found all around the world. So cyclones, based on the location where they are found in different regions of the world, can be classified into two principal types. First one is the extratropical cyclones or temperate cyclones, because these types of cyclones are most prominently found beyond the tropical regions of the world, primarily in the middle latitudes or temperate latitudes, hence the name temperate cyclones. Second one is the tropical cyclones, which are primarily found within the tropical zone. So these are the two types of cyclones. First one is the temperate cyclone, second one is the tropical cyclone. But in this particular video, we are just going to first study the temperate cyclone in detail, and in the next video, we are going to discuss the tropical cyclone in detail. So let's begin with the discussion of temperate cyclones now. Temperate cyclones. Temperate cyclones are basically the atmospheric disturbances which are associated with the low pressure systems and related wind movement. So temperate cyclones are also called as extratropical cyclones or wave cyclones, wherein, as the name suggests, extratropical, which means that these types of cyclones are generally found outside the tropical regions of the world. They mainly occur in the temperate regions extending between the 30 to 60-degree latitude north and south of equator in both the hemispheres. So they are generally found between the Tropic of Cancer and Arctic Circle in the northern hemisphere and Tropic of Capricorn and Antarctic Circle in the southern hemisphere, because of which these regions are also called as middle latitudes, and therefore the cyclones which are found in these regions are also called as mid-latitudinal cyclones. It is also important to note here is that, as we have studied in module 3, that there exists a high pressure belt or high pressure zone between 20 to 30 degrees north and 20 to 30 degrees south in both the hemisphere, which is a transition zone separating the tropical regions of the world from the temperate regions of the world. Similarly, we also have a low pressure zone which again extend between 50 degrees north to 70 degrees north and 50 degrees south to 70 degrees south, that is in both the hemispheres. And this low pressure belt again is a transition zone between the polar areas and the temperate regions of the world. And we have also studied that these temperate regions of the world or mid-latitudinal regions of the world are dominated by the circulation of westerly winds, which move from west to east. So any type of cyclones which are found in these regions of the world are heavily influenced by the movement of these westerly winds which are found in these regions of the world. So the temperate cyclones are also very much influenced by the westerly wind circulation which is found in the mid-latitudinal regions of the world. So temperate cyclones are basically the disturbances, atmospheric disturbances associated with again low pressure centers or low pressure cores, and you have variable wind movement which may range from feeble winds to very high cyclonic and very high velocity of winds, leading to storms and leading to destructive cyclonic conditions in the temperate regions of the world. Temperate cyclones, by definition, are atmospheric disturbances having the low pressure central core and increasing pressure towards the peripheral areas, wherein the winds move from the outer regions of high pressure towards the central low pressure. However, these winds do not converge in straight lines and rather follow curved path because of the existing Coriolis force and frictional force. So Coriolis force, as we have studied in module 3, is the existing force which lead to deflection of winds in the northern hemisphere towards their right from their source region, and in the southern hemisphere the winds are deflected towards their left from their source region. Because of the existence of frictional and Coriolis force, the winds which are moving from the outer high pressure peripheral regions of these cyclones seldom reach in a straight line towards the low pressure center. Rather, they follow curved path, giving the whole appearance of the circular whirlpool type wind movement in these temperate cyclones. So because of the profound impact of the frictional force and the Coriolis force, the wind movement is in anti-clockwise direction in the northern hemisphere, and it is in clockwise direction in the southern hemisphere. And all these winds which actually converge to the center of low pressure, they do not aggregate there. Rather, the whole system is characterized by converging and rising conditions near the ground surface, primarily because of the existence of low pressure at the ground surface and diverging wind in the upper atmosphere, primarily due to the existence of upper atmospheric high pressure. So you have a low pressure center which leads to the convergence of winds, but these winds do not aggregate at this particular low pressure center core. Rather, they ascend upwards towards the high pressure which is found in the upper atmosphere, and they diverge, due to which the low pressure center is always maintained at the ground surface so as long as the cyclone is alive. So you have this kind of pattern where you can see that winds are converging at the low pressure center. They are ascending upwards, and when they reach a certain limit in the troposphere, they diverge in both the direction. And where you have the high pressure at the ground surface, as you can see in this condition, high pressure at the ground surface, they tend to subside. And again, this whole process is continued, where again from the high pressure regions in the ground surface, the winds are attracted towards the low pressure core in the ground areas. Temperate cyclones, as the name suggests, are primarily found in the temperate regions of the world or mid-latitudinal regions of the world. But what is the reason that the temperate cyclones are formed in these mid-latitudinal regions of the world? Because temperate cyclones are primarily associated with the convergence of two contrasting air masses, wherein you have very cold, dense, chilly air mass which come from the northern part of the region, which collides with the contrasting air mass which is warm, moist, and light coming from the southern part of this region. And because these regions are the transitional zones also, so these two contrasting air masses converge in these regions, leading to the formation of extensive fronts, as we have studied in the previous video also. So when these two contrasting air masses try to converge, they are not able to converge. They lead to the formation of extensive boundary zones which are called as fronts. And these frontal regions of the world are basically the breeding grounds of the temperate cyclones also. So the polar front, which is created because of the convergence of two contrasting air masses, one coming from south, which is warm, moist, and light tropical air mass, and the other coming from north, which is cold, dense polar air mass, and the consequent formation of fronts in these areas are responsible for the origin and development of temperate cyclones. So basically, temperate cyclones are manifestations of extensive frontal activity, which is primarily seen in the temperate regions of the world. Therefore, these regions of the world are the major breeding areas of temperate cyclones and related weather conditions also. Since the formation of temperate cyclone is heavily dependent upon the frontal activity, the aggressiveness of different type of fronts, different type of air masses becoming aggressive in the frontal zone, and the consequent formation of low pressure center, because of which these types of cyclones are highly variable in shape, size, and they are also called as lows, depression, or troughs. And it is also important to note here is that since the temperate cyclones are the outcome of the frontal activity, they can be formed over land as well as ocean surfaces, covering extensive area in both the regions. So the formation of temperate cyclones is not only related to either land or sea. They can develop in any region where fronts become active and different air masses become aggressive. And these particular regions of the world, the temperate regions of the world, as you can see in this map also, they are dominated by the westerlies, because of which the temperate cyclones which are formed in these regions, wherein the wind movement is anti-clockwise in the northern hemisphere and it is clockwise in the southern hemisphere, and once these temperate cyclones are formed, they tend to move eastward under the influence of westerly winds which prevail in this particular zone of the world, and they are greatly influenced by the westerly winds blowing in these particular regions of the world, because of which temperate cyclones greatly influence the weather condition of the middle latitudes, because the prevailing winds in these regions having planetary dimensions greatly affect the weather of the entire temperate regions of the world in both the hemispheres. Now coming to the source region and track movement, as we have learned in the earlier slides that the temperate regions of the world extending between 30 to 60-degree latitudes are the most prominent regions where the temperate cyclones are formed. And once they are formed, they tend to move in easterly direction under the influence of westerlies. However, it is also important to note here is that once the temperate cyclones are formed, their tracks are highly variable. So their movement path is generally called as storm tracks because of their variability in the tracks and movement, and they don't follow a single direction or line of movement to a particular place, and it can be highly variable. But within this 30 to 60-degree latitudinal belts in both the hemisphere, you have certain specific breeding grounds which are most favorable for the temperate cyclones formation. So let's have a look what are those regions. So the most favorable breeding areas of cyclones within this temperate belts are located in the northwestern part of Pacific Ocean, and once they are formed in the western part of Pacific Ocean, they tend to move easterly towards the Gulf of Alaska. Then you have cyclones originating in the areas around Barents Sea. Then you have cyclones originating in the Gulf of Mexico, which also move northwards. So we will just understand the most favorable breeding areas of cyclones with the help of map. So as you can see in this particular map also that these temperate cyclones primarily originate between 30 to 60 degrees in both the hemispheres. And once they are formed, the wind direction in these cyclones is anti-clockwise in the northern hemisphere while it is clockwise in the southern hemisphere. And once they are formed, because they are located in the prevailing westerly wind belt, they tend to move eastward under the influence of westerly winds. And because westerly winds have planetary nature, they tend to influence the formation of temperate cyclones, their movement, their track, their path, their direction of movement in both the hemisphere, as you can see in this particular map also. But within the temperate region belt where temperate cyclones are seen, you have the areas which are most frequented by temperate cyclones, which are considered as the major breeding grounds of temperate cyclones. And these areas include, first one is the northwestern Pacific region where the temperate cyclones are found near the coast of Japan, and once they develop near the coast of Japan, they tend to move eastward towards the Gulf of Alaska, and where they finally merge with the Aleutian lows and they follow a southerly direction and reach as far as to the Southern California region also. And once these cyclones they move inland, they are occluded at the windward western slope of the Rocky Mountain, which extend from north to south for the entirety of North America. Another major important region is the western part of the Atlantic Ocean, which again move eastward under the influence of westerlies. So they also tend to move eastward and then they reach the North European region. Besides this, you also have the cyclones which originate in the Gulf of Mexico region. So the cyclones which originate in the Gulf of Mexico region tend to move northward and reach the southern North American region. Besides this, you also have cyclones which originate in the areas around the Barents Sea. As you can see in this particular diagram, also the areas around the Barents Sea, which also follow the eastern trajectory and enters the Central European region. Besides this, there are also the cyclones which originate in the Mediterranean Sea region, which also tend to move eastward, and sometimes the impact of these particular temperate cyclones is so extensive that they reach certain parts of Pakistan and India also, where you witness the winter rainfall induced by the western disturbances. So these western disturbances are nothing but the manifestations of the temperate cyclonic activity happening in the Mediterranean region, which when sometimes become very, very extensive, may reach to the certain parts of Asia also, like Pakistan and India, where you witness the winter rainfall induced by these particular western disturbances. So these are the major breeding grounds of the temperate cyclones within the temperate region belt. Similarly, the temperate cyclones which are found in the southern hemisphere also tend to move eastward under the influence of westerlies in these particular regions also. But it is important to note here is that the frequency of temperate cyclones is more in the northern hemisphere as compared to the southern hemisphere. Why? Because of the extensive variation in the nature of land and water and the percentage of land and water which is found in the northern hemisphere as compared to the southern hemisphere. Now, the development of the tropical cyclone can be observed with the progression of one of the recent most extensive extratropical cyclone, which was observed in the North Atlantic European region. So this is the storm Dennis, which was observed in February 2020, and this is one of the biggest and most intense extratropical cyclones ever recorded in the recent past in the North Atlantic European region. Why? Because the minimum central low pressure reached to somewhere around 920 millibars, which is very, very low in terms of the recorded extratropical cyclones history. So just observe that the winds coming from the northern regions are actually very, very cold, and initially the direction is westward, while the winds coming from south are warm and their initial direction is eastward. However, when the low pressure center is developed, they try to converge, and because of the existing Coriolis and frictional force, they kind of develop a circular pattern and they start revolving in a circular manner, giving it a whirlpool kind of rotatory appearance. So this low pressure center attracts the winds from all the directions, leading to the formation of temperate cyclones. And once this temperate cyclone is formed, because of the existing westerly winds in this region, it tend to move eastward. So while it was developed somewhere around in the western region of Atlantic Ocean, it started moving eastward under the influence of westerlies. Now just observe the massive extent of this particular extratropical cyclone. You can see that it has almost covered the entire North Atlantic region, and once it was formed in the western part of the Atlantic Ocean, it progressed and started moving towards the eastern region, where it reached the North European regions, which are in the temperate latitudes. And while it was moving eastward, it continuously maintained its anti-clockwise wind circulation also. So this is storm Dennis. So you can clearly see how extratropical cyclones developed in the northern regions of the world in this particular image, and how they progress once they develop and primarily move eastward under the influence of prevailing planetary westerly winds in this particular belt. Now let's observe some of the other characteristics of temperate cyclones also. If we consider size and shape, they are of different shapes and size. They can be circular, semicircular, elliptical, elongated, or even V-shaped. Along with this, there is a wide variation in the pressure differences also. The pressure difference between the center and the periphery is generally about 10 to 20 millibars, but sometimes it may also increase to 35 millibars also. So the pressure difference is highly variable depending upon that how extensive the extratropical cyclone has developed, and it may vary significantly in different regions of the world. Then there can be great variation in size and extent of the tropical cyclone. Average large diameter of an ideal cyclone is about 1900 kilometers, while short diameter measures somewhere around 1000 kilometers. So it may be pointed out that no two cyclones are identical in terms of their size and diameter, and the diameter may extensively vary, ranging from 150 kilometers to even 3000 kilometers in certain types of extratropical cyclones. Besides this, they may spread over a very large area. Nearly, they may cover 2500 kilometers of area over land or even over ocean. So they can develop over both the areas, land and ocean, with a very great spatial dimension also. And their vertical extent may also vary. The vertical extent of an average cyclone may range from 8 to 11 kilometers, and sometimes the cloud development in these cyclones may also reach to tropopause, that is somewhere around 12 to 13 kilometers in the upper atmosphere. Besides this, the wind system and wind direction in these particular cyclones also vary. The winds coming from south are warm and moist subtropical winds with eastward direction, while the winds coming from the polar cold regions from the north are primarily in the westward direction. So these lead to the differences in the nature and wind direction in different parts of cyclone when it gets developed, as we know that the wind direction is primarily influenced by the Coriolis and frictional forces also. So winds in the northern hemisphere are deflected towards their right. So this is just the case of the northern hemisphere. Consider this first. So winds from their source regions are deflected towards their right in the northern hemisphere. So polar easterlies are also deflected towards their right, while the westerlies are also deflected towards the right. Because of this, the winds blow from the periphery towards the center of the cyclone, but these winds do not reach the center in straight line. Rather, they cut the isobars at 20 to 30-degree angle due to frictional and Coriolis force. Thus, wind's direction is anti-clockwise in the northern hemisphere and it is clockwise in the southern hemisphere. Besides this, winds converge at center and ascend upward and diverge aloft to maintain the low pressure center while the cyclone is alive. So we have already discussed this in the earlier slide. Because it is a low pressure center at the surface, the winds from various directions converge, but they do not aggregate here. Rather, they ascend to the upper atmospheric regions where you have the high pressure, and they diverge in the upper regions of the atmosphere, maintaining the low pressure center of the cyclone till the time it is alive. The wind velocity also varies from region to region. It increases with the approach of cyclone and it decreases after the cyclone has passed, as we have just seen in case of storm Dennis. Initially the winds were whirling around in a very high speed, but later when the cyclone gets matured, the speed of wind is also reduced. The wind direction prior to the arrival of front is easterly and constantly changes with the advancement of cyclone. So as we have just observed in the earlier slide, that polar easterlies are existing in the northern part of the front and the westerlies are existing in the southern part of the front, and once they attain the circular motion due to the Coriolis force, there is a constant change in the direction of winds which were earlier primarily easterly in nature. Besides this, there is an immense difference in the strength of winds also, which are more intense in the eastern and southern portion of the cyclone, as you can see in the diagram, that in the eastern portion where the low pressure center is about to get created, it is very, very intense, and in the southern portion also where continuously the cold wind sector is trying to invade the region of the warm wind sector, the wind strength is very, very high. The temperate cyclone on an average move eastward with the average speed of 32 kilometers per hour in summers and 48 kilometers per hour in winters. Why? Because they are most extensively developed in the winter season. Hence, there is a variation in average wind speed also. Besides this, the wind direction and velocity is also influenced by the movement of upper atmospheric winds, primarily the jet streams. So we have touched upon this particular subject when we were discussing the jet streams also, but just take it for now that since the subtropical jet streams and polar jet streams are also active in these regions, when the cold air masses are colliding with the warm air masses of south, they are also influenced by the existing jet streams also, which are winds of very high velocity in the upper regions of the troposphere. So if the winds are ascending from the low pressure central region of the cyclones, they are also affected by the movement of these wavy jet streams which exist in the upper tropospheric regions, which may intensify the impact or direction or movement of temperate cyclones coming into their path in these regions. So if the storm front is east-west, the center moves swiftly towards the eastward direction under the influence of westerlies. And if the storm front is directed northward, as in the case of the cyclones which are developed in the Gulf of Mexico region, the center moves towards the north. But after 2 or 3 days, the pressure differences decline and the cyclone dissipates. So these types of cyclones are less intense as compared to the cyclones which are developed in the proper frontal regions of the world with east-west progression. In case the storm front is directed southward, the center moves quite deep southward, reaching Mediterranean region and to far eastern regions of Asia also, where you experience the winter rainfall caused due to the western disturbances also. So the role of subtropical jet streams and polar jet streams becomes very, very important when we say that the western disturbances reach to the Asian countries. So because of this existing jet stream above the Mediterranean region, these developed cyclonic disturbances are sometimes exaggerated and they are pushed to the Asian regions of the world, also bringing winter rainfall in certain parts of Asia like India and Pakistan. Now, we have discussed the major characteristics of the temperate cyclones, their source region, their movement, their path. Now, let's discuss their origin and development. The origin and development of temperate cyclone is best explained by the Norwegian model, which was propounded by two meteorologists, V. Berkins and his son J. Berkins in 1918. So they provided the first extensive model to explain the life cycle of mid-latitudinal cyclones and brought about a revolution and major advancement in the identification of temperate cyclones and understanding how they develop, how they progress, how they dissipate over the period of time. And they explained this temperate cyclone development through their very famous model, which is called as the polar front theory or polar front model. And it is also known by different names like wave theory, frontal theory, or Virgin theory to explain the life cycle of mid-latitudinal cyclones. So let's just see what polar front theory has to say about the origin and development of temperate cyclones. So it may be pointed out that the formation of front is the major cause for the development of temperate cyclones. And these fronts are formed due to the convergence of two very contrasting air masses of different physical properties coming from opposite directions. So the warm air mass coming from the tropics meet the dry cold air mass from the polar regions, and thus a polar front is formed, and it creates a surface of discontinuity between the two air masses, wherein the cold air mass being denser and heavier, and as the intermolecular space in the cold air is smaller, it subsides to the lower regions of the ground, and it occupies the lower regions of the ground. And such conditions occur between the subtropical high pressure belt regions and subpolar low pressure belt region, which are the transitional zones between the polar regions and the temperate regions of the world. So as the cold air occupies the lower regions of the ground surface, it is denser and it is heavier. So due to this region, the warm subtropical air is pushed up, and there is interaction between the two air masses depending upon their nature in terms of temperature and moisture condition. This interaction of cold and warm air mass create instability, and as a low pressure is created at the junction, particularly in the center of interaction, which leads to the creation of low pressure central core region. The center of interaction is that zone where the warm and cold fronts are differentiated, which later on become the central low pressure core of the tropical cyclone. The formation of the tropical cyclone is basically explained in 6 stages. The period of cyclone from its inception, which is called as cyclogenesis, to its termination, which is called as frontolysis, is called the life cycle of the cyclone, and it is mainly explained through this polar front theory through various stages. So through 6 stages, the whole life cycle of the temperate cyclone is explained. So let's discuss these stages one by one. The first stage is called as the stationary stage, or the beginning or the initial stage, wherein the cold air mass and warm air mass tends to converge along an axis, and nobody is invading the region of the other air mass, rather they are lying stationary along a region. So cold and warm air mass move parallel to each other, as you can see in this diagram, and stationary front exists. The existence of stationary is for a very short duration, till the time period only when one of the sectors of air mass become aggressive and the stationary front is eliminated. The second stage is actually called the incipient stage. Why? Because it is at this stage that the inception of the temperate cyclones begins. So now the warm and cold air mass starts pushing and invading into each other's territory, creating a wave-like frontal zone, as you can see in this particular diagram also. So cold air mass from the north is trying to invade the region of the warm air mass, and similarly the warm air mass is trying to invade the region of the cold air mass. So to the north and northwest, the area is occupied by the cold air mass, as you can see in this diagram, and it is called as cold sector, whereas opposite to this, the south and southeastern region is occupied by the warm air, and hence it is called as a warm sector. So now there is a development of cold sector and warm sector, wherein on one end the cold air is becoming aggressive and invading into the region of warm air, and at the other end the warm air is becoming aggressive and trying to invade the region of the cold air. So this is the starting of the temperate cyclone. Let's move on to the third stage. Now, the third stage, as the name suggests, is the mature state, where both the cold air mass from the north and warm air mass from the south is continuously aggressively invading into each other's territory. And here the cyclone is fully developed. Isobars becomes very closer, circular, and there is a sharp change in the pressure gradient. Low pressure attracts air from the surrounding regions, and a vertical updraft of air is observed very significantly. So now at this point of time, why? Because the cold air is very aggressively invading the warm air territory region, and the warm air being light and less dense is being pushed to the upper regions, creating a vertical updraft. And because of this updraft, a low pressure central void is created, which attracts the air from the surrounding areas, giving it a circular appearance. So the invasion of the cold air mass is greater than the warm sector, and the warm sector starts shrinking, as you can see in this diagram also. So continuously the cold sector is invading the warm sector region, and warm air is being displaced vertically upwards, and the cold air is continuously invading beneath the warm sector, displacing the warm sector, creating a low pressure central core region, giving whirlpool kind of appearance to the circular movements of winds along this created low pressure central core region. Now, the stage 4 is the beginning of occlusion stage. The two distinctively formed fronts are getting compressed because of their diffusion. So, the cold air from north is continuously compressing the warm sector, and the warm air is being displaced upward, and both fronts come close and finally merge together, leading to occlusion. Warm sector starts becoming narrow, and cold sector begins to take over the entire territory of warm sector at the ground level, tossing the warm air completely upward, leading to the formation of occluded front. So here in this diagram you can see the creation of occluded front, and as the occlusion begins, it leads to the dissipation of the cyclone. The warm air climbs over the cold air, and a series of clouds appear over the sky ahead of the warm front, leading to rainfall. So as the warm sector is quickly displaced because of the progression of the cold front from behind, it leads to the formation of cumulonimbus clouds, and very heavy precipitation takes place in these regions. Whereas at the end where the warm front is progressing, the displacement of the warm air along the warm front is comparatively less aggressive, which leads to the formation of nimbostratus clouds along the warm frontal region, causing low showers for longer durations. So stage 4 marks the beginning of occlusion stage. Coming to stage 5, which is the late occlusion stage, where more area of warm sector is occupied by the cold air mass, occlusion continues till the warm sector is completely displaced and warm air area is completely governed by the cold air. Pushing of warm air upward continues, and warm air cools down under the impact of cold air as well as by the adiabatic cooling, leading to heavy precipitation along the cold frontal region. So series of cumulonimbus clouds are formed in this region, causing heavy torrential rainfall primarily along the cold front. So by the end of this stage, the dissipation starts because the warm air is completely displaced above the cold air, and the cold air completely invades the territory of warm air. So once this happens, the low pressure central core conditions are lost, leading to dissipation of this particular cyclone. Stage 6 marks the dissipation stage or the cyclogenesis stage. The low pressure is completely eliminated and the normal conditions prevail again. The warm sector is completely displaced and it disappears, and the occluded front, which is pushed up, is also completely eliminated, leading to the conditions which were existing prior to the formation of temperate cyclones. So here the cyclone dies out, and this stage marks the death of the cyclone, which is also called as cyclogenesis. So these were the 6 stages of the life cycle of temperate cyclones, which was explained under the polar front theory given by Jerkins in 1918. Now let's discuss the weather condition associated with temperate cyclones. So as we have just seen that the temperate cyclones progresses through various stages, so weather conditions drastically change during the progression of the temperate cyclone. Different parts of the temperate cyclones are associated with the varying weather conditions because of different types of air masses and varying temperature and different stages of progression of temperate cyclone. So during the arrival of temperate cyclone, the air pressure suddenly decreases, the temperature suddenly increases when cyclones come closer. Wind direction also changes from easterly to southeasterly. The sky becomes overcasted with dark, thick, and low clouds. Now, after the arrival of the cyclone, the warm front precipitation starts. Cloud becomes thick and dark with nimbostratus clouds, and continuous precipitation is observed along the warm frontal regions. Heavy showers are occasionally seen for very long duration because of the creation of nimbostratus clouds along the warm front. As you can see in this particular diagram also, that the warm air rises gradually along the warm front, leading to the creation of nimbostratus clouds, and heavy to medium showers are experienced in these regions but for very long durations. Besides this, the warm front precipitation is followed by the invasion of warm sector, where you can see, because of high temperature and coming of warm air from behind, there is increase in air temperature and specific humidity also, and there is remarkable decrease in air pressure because of high temperature in this region. So high temperature is associated with low pressure conditions. Sky becomes cloudless and clear because warm air advances from behind with occasional drizzles. Now, as the warm sector progresses and the movement of winds in the cyclone is of circular nature, it is being continuously chased by the cold front from behind, and the cold front moves faster as compared to the progressing warm front at the other end, because of which it pushes the warm sector upwards and the temperature decreases. So as this cold sector continuously progresses, warm air being light is tossed up, and in the process the warm sector is continuously squeezed and it becomes narrower and narrower. The temperature definitely decreases, and because of decrease in temperature, the air pressure in this sector starts increasing. Formation of cumulonimbus clouds yield sudden and heavy precipitation of short duration along the cold front, followed by thunder and lightning. So as you can see in this animation also, as the cold front progresses, and because it is a steep boundary, the warm air suddenly rises along this cold front, leading to the formation of cumulonimbus clouds, and heavy precipitation along with thunder and lightning is a common phenomena which is observed along the steep cold frontal region. And this steep cold frontal region is followed by the cold sector from behind, where the winds coming from north are very cold, chilly, dense winds, and they continuously subside beneath the warm air, trying to completely invade the territory of the warm sector. So as the cold sector progresses, the sky becomes cloudless, as you can see in this animation also. As the cold sector is progressing, it is bringing cold, denser air along with it, which is subsiding, and there is the sharp rise in air pressure, followed by sharp rise in air pressure along with the sharp fall in temperature. The wind direction also changes and becomes westerly. So as you can see that initially the air which was coming from the northern regions was moving westward. Okay, but because of the progression of the cyclone, it is continuously trying to invade the territory of the warm sector, and because it has attained a circular pattern of movement, the winds become southerly first, as you can see that they are moving southward first, and then the direction changes to eastward under the influence of westerlies. So now they attain true westerly nature, where they move eastward. So there is a continuous change in the direction of winds also. So with the progression of this front,
there is continuous change in direction of winds, the velocity of winds, as well as the nature of precipitation which is happening along this cold front, wherein it is continuously invading the territory of the warm air, and the warm air being glide is squeezed up and it glides over the cold front, while the entire circulation is being pulled by the low pressure center, giving it a circular whirlpool kind of appearance. Finally, when the warm air is completely squeezed up, the occlusion occurs, and after the occlusion of cyclone, the pre-cyclone weather condition sets in, because when the warm air is completely squeezed up and it glides over the cold air, the cyclone dies off, leading to the establishment of pre-cyclonic weather conditions in the region. Now let's just observe the weather conditions which we have just discussed in the earlier slide with the help of progression of storm Dennis, as I have shown you in the third and fourth slide of this particular video. So just to give you a visual reference how various fronts progresses and precipitation occurs. So let's start with the first stage of storm Dennis, where you can see that the initial stage, the warm winds are coming from south and cold winds are coming from the northern region, and they attain a circular motion and starts rotating along this low pressure central core. So when they start rotating, there is the creation of cold front and there is also the creation of warm front. And as the cyclone progresses, as you can see in this video also, cold front is continuously invading into the territory of the warm air, and in this process the warm sector is continuously being squeezed up. As you can see in the second photographs that the warm sector is continuously squeezed. Just observe how narrow it has become as compared to the first picture. And along the warm front, the precipitation is very light for longer durations also. And further, as the cyclone progresses and as it becomes more and more intense, as you can see here. Now at this point, as the cyclone progresses, you can see that the cold front is continuously invading into the region of the warm air, and in this particular third picture you can see that the warm front has become very weak because of intense pushing from the cold front from behind. It is completely squeezed and tossed up above this cold front, and now this cold front has invaded the entire region of the warm sector. Just observe how this cold winds now have attained true westerly character, where they are moving eastward now. So as the storm progresses, the winds become more and more intense and the warm air is continuously pushed. The warm air glides over the cold sector and it leads to the occlusion state, and finally the cyclone dies off. So in the whole process, just observe that the eastern region experience more rainfall because of the progressing cold front, and the western region comparatively receives less rainfall. Because of gentle warm front, the precipitation is lower in the western regions as compared to the eastern region, where aggressive cold front is continuously progressing. So in this storm Dennis, because of all these conditions, the northwestern European regions experienced more rainfall, followed by thunder and lightning also. So this was all about the various stages of cyclone in with respect to storm Dennis and how the precipitation varies along the cold and warm front as the cyclone progresses and finally dies off, re-establishing the weather conditions existing prior to the development of cyclone. So as we have understood the main characteristics of temperate cyclones, the temperate cyclones may originate due to a variety of factors. So one of the primary factors of the origination of temperate cyclones, that is the convergence of contrasting air masses along the front, we have already discussed. But sometimes the formation of temperate cyclones is also related to the temperature variations and just pressure differences in any region. So based on this consideration, the temperate cyclone may be divided into three broad categories. First one is the dynamic cyclones. So these are the particular cyclones which we have just discussed, which are related to the convergence of two contrasting air masses along the front. So because of the convergence of the two contrasting air masses along the front and the formation of fronts to be the major cause for the formation of temperate cyclones, the dynamic cyclones are also called as true temperate cyclones also, because they exhibit the true characteristics, true conditions which are required for the development of temperate cyclones, and it leads to the formation of extensive fronts in these zones, and which leads to the formation of temperate cyclones. So they affect weather conditions of very large area in the temperate latitudes of the world. Besides this, you also have the thermal cyclones. So these types of cyclones are primarily formed due to the development of low pressure cells on the continents in the temperate regions during the summer time period, and they may also develop over the warm ocean waters in the winter seasons. So because of intensive heating of either land area during the summer time period or the ocean areas during the winter time periods, their low pressure cells are created either over land or ocean surfaces, which leads to the formation of thermally induced cyclones. So winds from all direction gushes towards this low pressure center, which may be again over land or over ocean, which creates the thermally induced cyclones. But these cyclones mostly remain stationary, not associated with most destructive natures. Then you have secondary cyclones. These types of cyclones are formed on the trailing fronts of a pre-existing primary cyclone. So if the pre-existing primary cyclone is a dynamic cyclone which has developed due to the contrasting air masses colliding along a frontal axis, when these type of cyclones are dying off, the secondary cyclones may originate from their dissipating trailing ends. Besides this, they may also develop due to passage of cold wind over warm sea after the occlusion of the main cyclone occurs. So mostly they are very short-lived and weak, but sometimes they also may cause damage depending upon the aggressiveness. So these were the types of cyclones. We have deliberately discussed the types of temperate cyclones at the end because the temperate cyclones or true temperate cyclones, which are dynamic cyclones, are the main type of cyclones. So we have discussed all the characteristics and everything of the dynamic cyclones, and the thermal cyclones and secondary cyclones are kind of less extensive cyclones and somewhere related to dynamic cyclones in one or the other way. So we have deliberately kept the type of temperate cyclones to the end. So summarizing the video now, temperate cyclones are storm systems emerging in the mid and high latitudinal areas away from the tropics, because of which they are also called as extratropical cyclones or mid-latitudinal cyclones or frontal cyclones or wave cyclones. So all these names are to denote the temperate cyclones only. Their formation is primarily associated with the convergence of two contrasting air masses and consequent formation of extensive fronts. They are low pressure systems which are associated with the formation of cold fronts, warm fronts, occluded fronts, and showcase extreme differences in temperature conditions, wind conditions, precipitation, wind direction, different types of sector. You have warm sector, you have cold sector of cyclone as it advances. While the warm front advances slowly, yielding continuous precipitation for longer durations, the cold front advances quickly, lifting the warm air suddenly, leading to heavy precipitation. The wind movement is primarily anti-clockwise in the northern hemisphere, while it is clockwise in the southern hemisphere due to the prevalence of Coriolis and existing frictional force, while the winds are converging to the low pressure center. Besides this, finally, the cold dense air, when it completely uplifts the warm air, it leads to the creation of occluded fronts, and this marks the beginning of the dissipation of cyclone, and finally the cyclone dies off. So these systems can develop over land and ocean systems covering extensive areas. Their origin and development is primarily explained through polar front theory, wherein the life cycle of the cyclone is explained through 6 stages of progression, from cyclogenesis, which is the inception stage of cyclone, to frontolysis, which marks the dissipation or dying stage of cyclone. So based on various conditions in which temperate cyclone develop, it can be divided into 3 broad categories. First one is the dynamic cyclone, which is actually the true cyclones formed because of the creation of fronts. Second is the thermally induced cyclones, mainly created due to the extensive low pressure center formation due to the very high temperatures either on land or sea. And then you have the secondary cyclones, which are primarily formed behind the trailing ends of dissipating dynamic cyclones. So these low pressure systems have significant impact on the weather condition, atmospheric turbulences, precipitation regime, extreme weather disturbances in the mid-latitudinal regions primarily, and sometimes they can be so profound that these disturbances may reach to far ends of Asia, and they may be experienced as western disturbances primarily in the winter season in the Asian regions also. So although these systems are extensively developed in the temperate regions, but occasionally due to the factors like prevalence of jet streams in the upper troposphere, they may be dragged to certain tropical areas or even higher latitudinal areas also, which are otherwise not frequented by temperate cyclones. So this was all about the temperate cyclones, their development, their origin, their source region, their track, movement, and characteristics of temperate cyclones. I hope the video was informative. Thank you.